Okay, in this question, we're looking at a radioactive beta decay of a neutron with a certain mass, which is at rest. So I have a neutron here, which is going to decay to a proton and a fast-moving electron. So the proton is moving slowly. So we're going to take into account the energy of the proton, electron, and neutron. And I'm going to explain what that means, what it means for the proton to be moving very slowly. So going back to the conservation of energy, we know that the total energy of the neutron, whatever it is, let's just write it like this, is going to have to equal to the total energy of the proton plus the total energy of the electron. Okay, so, and we already know that the total energy is equal to the rest energy of a particle plus the kinetic energy of a particle. Okay, great. So, and this is when we also know that the kinetic energy is equal to m naught, which is the rest mass of a particle, times gamma minus 1. So these equations are known in this chapter. Now what we're trying to figure out is that which one of these applies to which one of the particles that we're working with here. So I am going to change my color here. Oh gosh. So I am going to change to blue. And what I want to actually explain here is that since the neutron is at rest, I'm not going to have any kinetic energy for this. So all I'm going to have is the rest energy of the neutron to consider. That is equal to rest mass of the neutron times c squared. And we know that from E0 equal m naught c squared, sorry, E naught m naught c squared. And then for proton, we know that we have the rest mass, so I'm just going to write that down first. But for the kinetic energy, since it's moving slowly, I'm just going to explain in the corner what this means. Moving slowly, meaning that the velocity of the proton is going to be much less than c. Therefore, if I'm calculating the kinetic energy for that, and I'll have to calculate gamma, as we know, gamma is equal to 1 over square root of 1 minus v squared over c squared. So looking at this fraction here, if v is much smaller than c, therefore this whole thing is going to be much smaller than 1. Right? So if this number is going to be much smaller than 1 minus a very small number is going to equal just 1. Therefore, I can say that my gamma is going to be equal to 1 over root 1, which is equal to 1. So if gamma is 1, looking at kinetic energy, I have gamma minus 1, not plus, I have gamma minus 1. So that makes it equal to 0. And if that's equal to 0, the kinetic energy of the proton can be assumed to be 0. Therefore, I'm just not going to add it over here. Okay, but now when I look at the high speed or fast speed electron, I need to take into account both. So what I will write for that is I'm just going to leave it as total energy of the electron first, and then I'm just going to continue solving it. I'm just going to solve for the total energy of electron, and then I'm going to find out what the speed of the electron is, because I think it's just more simplified that way. All right, in this case, I'm just going to rearrange for the total energy of the electron. And I will have mass of the neutron, c squared, minus, because I'm moving this to the other side, I will have mass of the proton, and then times c squared. Now, since c squared is common in both cases, I'm just going to take it out, and I will be left with mass of the neutron minus the mass of the proton. So put this in my calculator. I should put in 2.998 times 10 to the power of 8. The whole number to the power of 2 times bracket open, another bracket open, and I'm just going to add the mass of neutron here, given to be 1.6749 times 10 to the power of negative 27, bracket closed, minus mass of the proton, which is 1.6726 times 10 to the power of negative 27. And then I'm just going to close that, close the bracket, and if I put this into my calculator, I should come up with a number that is very similar to this, pretty much the same as this, should be the same exact number, times 10 to the power of negative 13 joules. So this is the total energy of my electron. And this includes the rest mass as well as the kinetic energy of the electron. So going back to the next page, I will actually have to calculate the speed of the electron. So this is how I'm going to do it. Since I have the total energy of the electron, and that is equal to E0, E naught, plus the kinetic energy, I can rewrite that as rest mass of electron times c squared, and the rest mass of the electron again times c squared times gamma minus 1. So this is E naught and this is kinetic energy. This is just all given. Now the only thing I'm going to do here is that I see that they both have MEC squared in common, so why not just factor one of them? So I will factor out MEC squared, and I will be left with, so then I have to divide both of these by MEC squared. And for this one I will get 1, and for this one I will get gamma minus 1. Okay, now in this bracket I have a positive 1 and a negative 1, which will cancel out. And this will equal to mass of the electron, c squared, and then I will only be left with just gammas, which I'm going to write on the back. I'm going to write the gamma here. Because these are multiplication, it doesn't matter if the gamma goes in the front and the back. I just like to see it in the back. It just makes me happier. All right, so we have the total energy here. Now what we're doing is that we're solving for gamma, since we have the total energy from the previous page. So I will have gamma equal to the total energy of the electron over mass of the electron times c squared. So I got the total energy to be 2.0672 times 10 to the negative 13 joules. Right? We have that from the previous page. And then, so I will have the mass of the electron, which is 1.0109 times 10 to the negative 31. And then this times the speed of light to the power of 2. Just pause this video, put the numbers in the calculator, and you should come back with this number. 2.5248. I'm just going to keep these significant digits to make my answer a little better. So I'm just going to keep gamma as is. And I'm going to move and continue to plug in. And remember what we have for gamma. And I'm just going to rearrange this page. So I'm going to go here and I'm going to write the equation I had for gamma. And I have 1 over 1 minus v squared over c squared. Now what I want to show you is that how I can actually rearrange this so to solve for v. In order to do that, I can actually square both sides to get rid of the square root. I don't like seeing the square root there, so let's do that. Gamma squared is equal to 1 over 1 minus v squared over c squared. And then we're going to rearrange this. So I'm going to solve for this. 1 minus v squared over c squared is going to be equal to this times this divided by this. So I will have 1 over gamma squared. But I'm just going to move it to the other side. So v squared over c squared, I have a 1 here, minus 1 over gamma squared. And then once I have this, I'm just going to solve for v squared. I'm going to bring c up. So I'm going to multiply by the other side. I will have v squared, 1 minus 1 over gamma squared times c squared. And in order to get rid of the power here, I'm just going to square root both sides. I'm going to be left with v equals square root of 1 minus gamma squared. And then square root of c squared is just c. Perfect. Now all I need to do is to plug in gamma. So square root of 1 minus 1 over, and my gamma from a previous page, I had it to be 2.52498. So in my calculator, I will put in 1 minus, bracket open, 1 over 2.5249, bracket close, then take the square root of it, and I will get v equals 0.918c. So make sure you put these numbers correctly in the calculator so you get the exact same number as me. Now this would be the velocity of the electron as nucleus is going to the neutron is going to decay into a proton and an electron. That's about it. If you have any questions, please comment them down below. Like this video. Thank you so much for watching.